the last lecture before the term test. We will finish this bit about friendship, and in particular looking at overloading the input operator. And you will see it's very similar to output operator overloading. And I have adjusted a little bit for the demonstration file, CPP file for string DT. Have a look there, because I have implemented both output operator and input operator as non-friends of the class, using just the public data or the public method of the class. So there are two versions for string DT. You have for classes two different examples in this week stream. One is about clock, which uses simple data members, integer type, and the second one is about string DT, simplified string class, which uses pointer data members. And for this string DT, I have implemented output and input operator as non-friends. In the previous version, the input operator was friend of the class and output was non-friend using print method, which is a different approach. So I would recommend you to look at those demonstrations and see if it helps understanding of the material we have covered. We have seen that for output operator, because it's a method of the OStream type, it's not possible to implement output operator overloading as a member of a user-defined class. If you have the student class, you can't make it overloading the output operator. You can't make that operator member of your class. It is to be outside your class. It's a global function for your point of view as a provider of a new type. And we looked at how to implement the output operator as a such non-member of a class. And we have seen two approaches. One is to declare a friend of the class. The class has to give this privilege. And then, because our operator is a friend of the class, has access to all data of the class, private and public. The other approach is to use this operator not as a friend class. So the class does not give the friendship privilege to the operator. Therefore, the operator has to use whatever is public in the class to perform its job. And this requires the class to make sure that provides enough tools so the operator can do its job. And between output operator and input operator, which one do you think is more difficult to implement?
Both.
Both. One option.
Input.
Both?
Because you're modifying the private members.
Right. We will have a look. The problem is with the input, we are very creative. Users can make a lot of mistakes. And because you ask for an integer and the user enters a float value, things can go down very quick. Always the input operator requires a lot of checking if it has to be done properly. So be aware that input operator requires more thinking, but for the moment we assume that we deal with careful users and we don't do much checking of the input provided. we assume that things are going to be entered as we expect them. So the references are there. Oops. There. From beginning slideshow. I am going. Yeah. These references are good, and then we look at the input operator straight away, and I will point out what is similar to the output we have seen last time. The orientation of these two symbols, it's different for input. We expect something from the keyboard or the file to be stored in our variable. So the input operator name is this, as you know. And then the parameters are in general two types only, in general. And the first parameter is related to the input stream. So it's input stream by reference, because we are going to change the input stream as we read data. This is the last thing which appears in the implementation, because it's returned to allow for multiple inputting, right? So like in the output operator, this part is here in stream reference, return value in stream reference. For output, O stream reference, very similar, which helps with learning the tool. But the second parameter is where we are going to store data entered by the user, as opposed to output operator, which has no job of changing that object. The input operator has the task of changing that object. Therefore, this has to be passed by reference, no constant. Reference to complex. So this is the first difference, besides the orientation. But as you can see in the function, we have the same kind of arrangements. We have here the thing which we use to read data, and we assume that we have put some prompt saying, please enter, and we have put some prompt somewhere outside this, where we have said, please enter a complex number as this, round bracket, some integer value, -3, comma, and another integer value, assuming this is the real part, this is the imaginary part. We assume that we have told the user that we expect this, and we assume that the user pays attention, and we assume that the user enters 1, 2, 3, 4, 5 items. 5 items, we assume. So if the user doesn't enter this, we are in big trouble, because everything here will break down, right? That's why we will have to use exceptions if something goes wrong. But for the moment, we are just looking at assuming that the user is disciplined and pay attention, and it will enter exactly these 5 characters. How is our code to be written? We use local variable to read the data which is not part of our type, right? So we will use this character to read this and ignore, read this and ignore, read this and ignore. And we just store these 2 values because we are interested in the real and imaginary part, right? So we expect here to have that bracket which is ignore, and then the first real value, or the number which is the real part, is stored in here. Something similar you will have for your assignment when you implement input operator for your student. You read some data, because their operator has to be a global function, not friend or whatever. You will have a student here, and you will have student dot set name first, whatever you have read. You use in to read a string for the first name, and then you have your student variable dot set name to whatever was read here. Of course, this is a different statement, and you do this for every data member of your type. In this case, this is to read the comma, this is to read the second value, and this is to read the last bracket. And with this, we assume that we end up with this parameter with the two values which are of interest for the type. And then, because we want to allow something like, if we have two complex values, C1, C2, we want to perform from file, doesn't matter, or from standard input device, read first one, read next one, semicolon. Okay, so with this, the input stream is ready to get the second thing. Once again, simple, and you can say this is as simple or as complicated as the output operator, but be aware that we expect something here, and if the input is not as like here, probably we have to go inside the while loop and keep repeating, asking for proper data to be entered, right? This would be in a safe environment if we really want to make our input operator very safe. But for the moment, we are just looking how to provide facilities which are available for primitive types, for types we define. And as you can see, we can do quite easily implementing some functions. But you have to know which should be method of the class, which should be global functions, how to write them, what are the parameters, and it's fixed somehow for both operators, input and output, the name of the operator, this type, reference to is iStream or OStream is what you return, iStream or OStream, and you make sure that you return that stream passed in, and the second is necessarily an object of the type you define. And that object is either constant reference or simple reference, depending on what you try to do. When you just display on the screen on a file, constant reference is perfect because you don't change the object. But for reading data into C, we can't have it constant. We need it just by reference. Right. And these are the operators we are covering. As I said, there are 38 operators with C11, 39 for C14, but we looked at subset. Some operators are more difficult than the others, but there are some simple rules you should be aware of. You overload operators just to make the type you design easier to use. Easier to use. If you have very complicated operator or function names for your types, who will spend time to learn all those names and then try to use them properly? So this is one. Reduce learning curve, and then because we assume that you use for people who provide those operators, keep the meaning. Plus means either addition for numbers or concatenation for strings. You can't say that plus for, if you implement it for a type with numbers, will do exponentiation. This would be a very big mistake. You can, but it will not help with code defect rate. people will make mistakes if you change the meaning of an operator. If you create operators that confuse your users, you do not use overloading as it should be. Okay. Assignment comes with some checkings, both copy and move assignments. We have seen that it's good to have compound assignment operators, and then based on the definition of this, the simple operator plus, minus, multiplication should be defined. This changed the object on which they are called, so you have to remember this. Then, only existing operators can be overloaded. In Haskell, you can introduce new operators, but not in C++. And you will see Java does not allow you to overload operators at all. So there are different degrees. Now, if you overload an operator for your type, at last one operand, one parameter of that operator should be of your user, of your type, of your new type. You can't overload the plus operator for integers, because integers are not defined with classes, or for float, or for boolean, or for whatever. So primitive types, you can't overload the operators. So 5 operators you cannot overload size of. The tertiary operator we have talked about, a Boolean expression. If it's true, the first part is executed. If it's false, the last part. This is member operator, which is not allowed to be overloaded. Scope resolution, and dereference operator. Dereference. It's not possible. At this moment, you probably know that we have here this overloaded in the language itself. It can be multiplication between numbers and dereference as well. So it's a very simple example of using the same symbol for different things. Right, now index operator. This is a function operator. If you can redefine what it's called, a function, construct functions using that in a specific way, like a class, but we don't go there. Assignment operator and arrow operator working on pointers. They are member of the class and non-static, so this can't be class methods. Again, stressed, don't change the meaning of an operator. If it's assignment, it has to do assigning. Don't use assignment operator to perform multiplication. Assigning and something else. No changes. Besides, these global functions being friend of a class, we can have all type of combinations. In this example, we have a class A. Because we're using class A, the class B, you have to let the compiler, I will provide definition for B later on. This is called forward definition. Forward declaration. You let the compiler know somewhere, I will make the definition of the class B available to you. Because using F with parameter of type B, the compiler has to know what is B here. But we define B after the class A. So the way to solve this problem is just name the class and then do the implementation later. It's fine. So as you can see, we have a class A which has some methods, And the class B says that ZF here, A, F is a friend of this class. At this moment, class B allows F in A to access data member in B, correct? So it's a friend of this class. Notice no specifier, means it's private. This is how it works, right? Therefore, X is private in B, but because this F is friend, our function F in A can access it. But J, the other function in A, is not a friend. It doesn't have the same privileges. Therefore, if J, which is a normal method of class A with no privileges towards B, when it tries to access private types, it's not allowed. You get an error, like here. Of course, both F and J can work with anything which would be public here. For the moment, we don't have anything public. Everything which is public in class B, it's available. Right. Another thing is, friendship is not symmetrical. If class A says that other class is my friend, then other class, which is this one, that class can access everything here, but this class cannot access private part of this, right? So it's not symmetrical. Class A declares this class to be its friend. Therefore, this class has access to this. As we see, this class does not give any privilege to this. In other words, A class can't access anything which is private here, if we have private things. So be aware of non-symmetrical relationship here. And this it tells you what's happening. This object is of this type, and then OC is of this type, right? Then we call this object method. Nothing new here. It's a method of the type A class. So it calls a print from here, and because secret was initialized to 0, we get that one. Now we go and see OC, which is of other class, which was declared friend, and we see that inside this change, we access data member of this type of object. AC secret is changed to X, to the second argument. Therefore, when this is called with second argument 10, we end up with our object. This is, the object is this, a synonym, right? This object's secret value is changed to 10, right? Therefore, when we call for our object, this we get out 10. Right. This can become a lot of complicated, more complicated than this if we give a lot of friendships or try to declare just one method of a class to be a friend of the other class. Things can be a little bit difficult to read and understand. So these are used not extensively, but they are used. So you should know it. Friend functions have main purpose to allow implementation of non-member functions which need access to private data of a class. This is friendship, but it has to be accorded with a lot of thinking, and only if you can't do it any other way, if you can't use what is private in the class to perform the job, if you can't do your job in the function using the public part of the class, then maybe you cannot give friendship. But other than that, avoid it. This is a dangerous thing. To allow too many friends to the class, things can go quite error prone. In multi-threading, concurrent programming, and with this friendship and with inheritance, can be very bad. So, you always have to wait. Is it good to have some operators overloaded for the type I provide? Are the users going to need those operators? Because otherwise you make your class too cluttered and some people might not want to use it. So there are different rules. You have to respect the names of the operator, plus, minus, whatever. Some can be defined member functions, others global function, and friendship. This is something is some relationship which you have to make sure that is given because it's really necessary. So now we go for review and test preview, and as I said before, you are supposed to know everything we have covered, starting with standard predefined stream variables. Now you see CR, CIN, and CR are various type of stream variables which are predefined for us to use them with extraction and insertion operators needed. We have looked at C++ strings, and by now hopefully you have noticed that it's much easier to use them than C-style strings, which are dangerous sometimes because you need a very good understanding of how pointers are used and how functions are defined for C-type strings. And the C++ strings come equipped with a lot of methods, including overloading operators for concatenation, test for equality, non-equality. Define is to be avoided in C++ because you can't have the compiler checking the types. This is the main issue. The compiler is your friend. It can discover errors. The best way is to use constant variables or inline functions to obtain the same benefit of speed up. We have seen that overloading is provided by C++, and by now you know classes, constructors are overloaded, operators, assignment, output operator, input operator, they are all overloaded. We can use parameters which get values in the heading of the function, default parameters, and again in constructors. For default constructors, this is a very good way to initialize data. References are introduced there to avoid, again, pointer notation and pointer mistakes. There are kind of pointers behind the scene, but be aware there are differences between references and pointers, as we have seen. And the preferred way for passing variables of user-defined type is by call by reference, constant or non-constant. We looked at dynamic memory, and we have seen that delete and new are the two mechanisms to deal with row pointers, as they are called. Simpler syntax work well with what is provided by C++ constructor destructors. Be aware that using null instead of null pointer in your assignments exam test is penalized. You will use null for Java, but not for C++, so make sure that you are aware of that. Memory, we have seen that we have local memory, the local variables which are defined on stack n. Dynamic memory, that memory which is allocated with new. That is the simple definition is memory allocated on the heap. And variables are well defined as long as they are within the scope. We have seen that classes, in a simple way, are abstract data types, user-defined types. If you provide all mechanism, all operators for your types, all methods required by your type, then the user sees your type like it sees integer, float, bool, and works with them in a similar way. And there is, in terms of displaying it, reading data, whenever you look at some topics we covered, this user-defined type, string, for example, compare with what you provide for your student, what you provide for your course, and see how it compare. We know combining data and operation and putting in place visibility, restriction, private and public, who can use what part of your type is what object-oriented programming is about. We will talk about protecting later. Classes are cookie cutters or blueprint or a mold for instantiating variables which come equipped with the same tools if they are of a class type. Variables of class type are called instantiation objects, and we work with them, with those variables, instances of a class, using the public part of the class, in particular accessors and mutators, method of a class which give us the opportunity to perform things we want, perform tasks using that type you define. And some terminology, constructor destructors, which are called by the system for us. We have to put them in place. You have to know what type of constructors we talked about, when you have to implement copy constructor, move constructors, as opposed to implementing just a simple import constructor. So these are things which will come again for all the future lectures. We will talk about inheritance templates. They all have to deal with constructors at some stage. C++ is good for extending features. Operator overloading is one of this facility. And we have all sorts of operators, taking one operand unary like plus plus I, or binary, or operators defined with other symbols, index operators. We talked about member functions or non-member functions, and some operators can be implemented either way. We can have plus operator implemented either as a method of a class or as a global function. It depends on the task to be performed and how often that operator is used and how fast it is implemented as a global function as opposed to as a method of a class. Friends are introduced in C++. Java doesn't have it. This facility, you can't have friends in Java. But in C++, you are allowed to give permission to other classes or functions to access private data of the class itself. So, this is all we have talked about in the 5 weeks. This is the 5th week, right, up to today. And you have seen examples in the tutorial, in your assignments, in the lecture, in the code, in your stream. Everything is considered read, understood, practiced with. So the term test can have any questions related to these topics. It's Monday in the lecture room, which is normal lecture room, right? 12 to 1, QB6. Bring your ID, I will check it, and we'll see. I will give you the paper on which you will write your ID, name, family, name. As you will see, you are not to worry about what files to include. Assume that include IO stream and using namespace std was there for the example code I put in place or for the code you have to write for the classes. Don't worry about including whatever, right? So all header files are there by default. It's 20 marks. You have 50 minutes for this test. And probably know that you have on your stream the test from 2012. 3 questions. If you look at it's similar for this test. One question you will see, you will be asked is of 7 plus 8. One question is 2 parts. 7 is to write a class, and you will be to write just the listing of the class. What are the public data member? What are the private? What are the public methods? What are the private data member? As according to the specification, right? A class, student, you will be said, for example, which has to have 3 data members, first name, last name, and ID. And for this class, you have to provide a constructor, or index operator, and blah, blah, blah. Probably three things. So you have just to write the listing of the class for 3 marks. Just listing, class name, public, private, good names, curly brackets at the end, and semicolon. Just listing, function prototypes and method, data member types and names. And then you will have 2 functions to write. One will be overloading input or output operator for your type as a friend or non-friend of the class. And this will be 2 marks. And write one of the method or in the class, or 2 methods in the class, which mostly are very simple, like get name. return name, whatever. But they have to be outside the class, not in line. So you have to say string, student, column, get name, or empty brackets, return name. Something like that, very simple. Don't get very excited. And for this you get another 2 marks. 1 mark is write how many marks of 20 you think you will get for this test. And the error margin is 3 marks. If you are wrong with 3 marks, you will get 1 mark for your answer. 2 reasons for including, and you will have similar thing for the final exam. 1 mark to assess your performance, to see are you aware that you are doing wonderful or you are not doing so wonderful, 1. And the second reason is when you have to decide how many marks, you have to go through each of your answers. So if something was missed, you might be aware, oh, I forgot to answer this. Let's answer, and then, so it's a revision of what you have answered. So this is, first question is 8 marks. Second question is 6. And you will be given 2 classes. One will be defined with some method, another with some other method, and you will have very short questions like, does the first class have a constructor? Does the second class have a move assignment? You just look at the prototype and say yes or no. 6 questions about this kind of things. What is based on the listing of the class. And for each correct answer, you get 1 mark. And the last one is about reference calling, call by reference versus call by value. And this I have went over an example, and I have prepared an example for you to go over. It's similar to what we had for the term test last semester, but it's changed a little bit. So have a go to this simple exercise and see whether you can do it. It's once again trying to find out whether you how to work with call by reference, and can you distribute this, can you distribute this, please? I have only 20, how many we have here? 20, wow. I might have 1 extra, so I want it back if it's a... Yep. Have a go. So it's call by reference, call by value, who has classes, just to make it more interesting. Thank you. So have a go and try to find the answer. Quick. Try to find what is the answer. You don't have much time, and for the exam you won't have much time. So you will have to work a little bit alert. lot of writing going on. Don't copy the code. You waste your time copying the code. Try to see how the memory is arranged. Right, so this was last semester, but this semester will be also with first function, second function, but totally different kind of stuff, with classes, stuff like that. There is one set, there are probably 3 numbers first output from test, second function. So test first function is called first, all right? And first function takes P1 by value and the pair by reference. Therefore, num, which is called by value, it's copied, but then it's not changed outside the function, right? Because it's copied, and by the end of the function, that 1, 1, 1 is discarded. So at the end of, after the first function, we have num still 0, and pair is changed. If you look at first function, after the test first function, what we have is for num, the value is still 0, but because pair was called by reference, we end in P2 with 1, 2, 2 and 1, 3, 3. So pair after the first call is 1, 2, 2 and 1, 3, 3. Because it was called by reference. Clear? Right. So this is after first function. And then we call second function with this, and it is calling by reference for num, or P1 is called by reference. Therefore, we get num and P1, both num and P1 now are 377 inside the second function. And pair is called by value, but we changed P2 to 388 and 399. So be aware, we are not working with this original value. It's copied, but then we have P2 first set to 388 and P2 second set to 399. Right? It was P1 first was copy 1 to 2, but it was changed to 388. And these are the values which are displayed from inside second function. Therefore, the first output is 377, 388, 399 with commas. 3 easy points. And then for getting out of the function, this I ignored because it was called by value. They were called by value. Therefore, we have outside num equals 377, that P1. And then we have pair, save, comma, pair equal pair first 122 and 133, because this was called by value 122 and 133. Simple, you can take a little bit of a program and run it and make sure that you understand this. Right, so this will be another sequence and we'll finish. Closed book, no smartphone, please. Bring your pens and your ID. All answer should be written on the paper. I give you even a piece of paper to use computation, but not for marking. You can leave the room, but not the last 10 minutes, because last 10 minutes everyone stays, so we all finish right here. This is on stream already. Everything we have covered is in the test. And see you on Monday for the test, probably 5 minutes before success. That's part 2 of question 1, how many marks. It's part of your learning process.
Yeah.
If you have questions, you can send me email, tutorial on Friday. Sorry? Yes, you can. Okay, we go out all this.
Yeah.
There is another file.